Hello, Math 1050. This is section 2.4 and 2.5. Talking about lines today. There are a total of 9 topics. First, want to just talk about slope on lines. So if a line is increasing from left to right, we say that's a positive slope. And if a line is decreasing from left to right, we call that a negative slope. A line that is horizontal has an equation that looks like y equals a number, and that is a horizontal line with a 0 slope. And then if you have a vertical line, that's x equals a number, and that would be an undefined slope. So your first topic is to just classify slopes. So this one is going down from left to right, so it's negative. This one is horizontal line, and so we say the slope is 0. This one is a vertical line, so that slope is undefined. And this one, the slope is going upwards or increasing from left to right, so we'd say that's a positive slope. So now we're going to find the particular slope because these lines are on a coordinate plane, so we can see the grid there and count off the slope. So slope on a grid, if we're counting it off, it's the rise over the run. So this one is going down 1, 2, 3, 4, and over 1, 2, 3. So negative 4/3. This one is going up 1, 2, over 1. Oh, I said 2 and I wrote 1. Or you could think of it as up 4 over 2 if you're using their 2 dots. But if you do have it in an unsimplified form, you want to make sure that you simplify it. So the slope formula, we talked about rise over run. The slope formula is literally the change in y, which is the rise, so y2 minus y1, divided by the run, or the change in x, which is x2 minus x1. And this formula is on your formula sheet. It is just below the circle equation, and you have it right there on your formula sheet. So we're going to find the slope through 2 given points using that slope formula. And then we have to classify it as horizontal or vertical. So the slope is y minus y over x minus x. It doesn't matter which point you think of as point 1 and which point you think of as point 2, as long as you're consistent and put, the x and y of the first point first and the x and y of the second point second. So negative 3 minus negative 3. So be careful with your negatives here. The formula itself has a subtraction, so you sometimes are subtracting a negative. And then 6 is our x value. Not comma. Subtract negative 8. So 3 minus negative 3 is 0, and this is over 14. That is a slope of 0, which makes this a horizontal line. Another set of points here. So if I threw these into the slope formula, I have negative 5 minus 4 over 6 minus 6. This is a negative 9 over 0, and division by 0 is not allowed in math. It's undefined. So this is an undefined slope. And so that means it is a vertical line. All right, your next topic will be to graph lines, and the lines will be given to you in slope-intercept form. Slope-intercept form of a line is mx plus b. So m is the slope, and b is the y-intercept. So we're going to start with the y-intercept. And if you're good at translations, you can just think of this as shifting the function up 5 units. So that might help you remember that that's a y-intercept. So we start with that y-intercept, and then we count off our slope of negative 1/2. So down 1 over 2. And in ALEKS, you just have to find those 2 points, and then you can sketch it. on paper or on tablet, it's a little harder to get a straight line with just 2 points, so I'll dot a couple of them. A little off. Anyway, there's our graph. You'll have another topic where you're graphing a line, but it is not in slope-intercept form. So in that case, you just want to manipulate the equation until you have it in slope-intercept form, also known as solving for y. So we want to get this y by itself. So I'm going to start by adding the 4x to the other side of the equation. And then I'm going to divide both sides of the equation by 3. When you divide by 3 in this situation, you can kind of think of it as dividing each term by 3. And then you can graph it by finding the slope, the intercept is -5, and the slope is up 4/3. And from there, you'll have your graph. So now we're going to, the next topic is writing an equation in slope-intercept form given slope and a point. So slope-intercept form, our goal is y equals mx plus b. We want it in this form. But to start with, we do know the slope. So we do know that m will be 1/3, but it's not giving us the y-intercept as the other point. So we've got to use this other point and the slope and then manipulate our equation to put it into this y-intercept form. So the point slope formula is y minus y1 equals m times x minus x1. So this is our x1 and our y1. So it's y minus y1, so minus -4, equals 1/3 times x minus x1, which is 7. So our goal is to fill in the y1, the m, and the x1. And that gives us this equation with x and y in it. And then we would just want to solve that for y. So y plus 4 equals, and we're going to distribute this, 1/3 x minus 7/3. You're going to probably have some fractions come up. That's going to be okay. Just keep those in fraction form. Don't turn them into decimals. And then we're going to subtract 4. So that gives us y equals 1/3 x minus, and in your calculator, you can calculate -7/3 minus 4, or you can, 4 is the same as 12/3. And so you can do it, manually if you want, or you can just do it in your calculator. So 19/3 here. And so that's in the form that we want. 1/3 is the slope and -19/3 is the y-intercept. Okay, this topic is average rate of change. An average rate of change is when you're having a function that is not a straight line, like this blue graph right here. Average rate of change is like when you are finding what the average slope of that curve is between 2 points. So you're thinking about this secant line that connects those 2 points, and then what is the slope of that line? So it is still just a regular slope. It's still just a rise over a run to figure out the slope there. But if we write this equation in function form, it looks like this. The slope is f of x2 minus f of x1 over x2 minus x1. But these are just y's, remember? That's the same as y2, and that's the same as y1. So the average rate of change formula is not on your formula sheet, but the slope formula is. An average rate of change is just a slope for an average slope for a curvy function. So we want to find the average rate of change of this parabola between 4 and 7. So we need to know the y values. Essentially, we just want to think about 2 points on this graph, 4 something and 7 something. So if we sub in 4, f of 4 is negative 4 squared plus 2 times 4 plus 9. And that is 1. So one of the points on that parabola is 4, 1. And then f of 7 is negative 7 squared plus 2 times 7 plus 9. And that is negative 26. So if we're figuring out the average rate of change is the same as slope. It will be negative 26 minus 1 over 7 minus 4, which in this case simplifies to negative 9. And you can just punch that in your calculator and it'll take you straight to that negative 9. Okay, the last two topics have to do with parallel and perpendicular lines. So if you have two lines that are parallel, that means they have the same slope. In this case, those two lines both have the slope of 3/5. If two lines are perpendicular, that means that whatever the slope of one of those lines is, the other one is the negative reciprocal. So you change the sign and you flip it over to get that perpendicular slope. So for this first line, y equals negative 2/5 x plus 1, the slope of the perpendicular line would be positive 5/2 because the perpendicular line has the opposite sign. So we change it to positive and then we flip it over to get 5/2. A parallel line would have exactly the same slope, so negative 2/5. For this topic, you will have to tell the relationship between different pairs of lines. It's going to give you 3 lines, and you have to say whether line 1 and line 2 are parallel, perpendicular, or neither, line 1 and line 3, line 2 and line 3. So some of the lines will already be in slope-intercept form, and you'll be able to see what their slope is straight away. Others of them you'll have to solve for y to get that slope visible. So in this case, if we divide by 4, we can see that this second line also has a slope of 3/4. Line number 1 is a little more work to solve for y. Negative 8x. So I subtracted the 8x, and now I'm going to divide everything by negative 6. So we get y equals 4/3 x plus 1. So in this case, the slope is 4/3. So if I'm comparing the different pairs for line 1 and line 2, those are reciprocals, but they aren't negative reciprocals from each other. So that pair is neither parallel nor perpendicular. Line 1 and line 3, if I compare, also neither. And line 2 and line 3, they have the same slope, so they are parallel. You will have perpendicular ones come up. This is just a coincidence that it's neither on those. All right, that's it for lines. So let me know if you have any questions. Thank you.